Okay, hello everyone in a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2017, first session, third exercise. So the title of this exercise is converging lens. The aim of this exercise is to determine the focal length of a converging lens L. For this, consider a luminous object AB and its image A prime B prime given by L as shown in document 3. So they mentioned the document, then now I can use it. Number 1, they are telling me that the image A prime B prime is virtual, justify. So in other words, they are asking me about the nature of the image A prime B prime. Notice that here the object AB is pointing upward and the image A prime B prime is pointing upward, which means that the image and the object are in the same direction, which means that the image is erect with respect to the object. And whenever the image is erect with respect to the object, then the image is virtual. So let's write down, since it is erect with respect to the object AB, then the image A prime B prime is virtual. One can answer this question in another way. Notice that here the object AB and the image A prime B prime are on the same side of the lens, which is in front of the lens. And whenever the object and the image are on the same side of the lens, this means that the image is virtual. Then let's say that since the object AB and the image A prime B prime are on the same side, then the image A prime B prime is virtual. Okay, so no need to write both answers, either of them is accepted. Okay, so now in number 2, they are telling me reproduce on a graph paper and with the same scale the figure of the above document. Notice that here the direction of propagation of light is from left to right. And whenever we need to reproduce, we always start by drawing the optical axis at the center. This is the optical axis, having the same direction of propagation of light from left to right. And then we place the lens L perpendicular to the optical axis at the center, using the correct symbol of a converging lens. And we know that the intersection between the optical axis and the lens L is the optical center O. Okay. Now the point A is located 3 divisions in front of the lens on the optical axis. And the point B is located 1 division above A hat is found on B. Now let's trace the object. And now the point A prime is located 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisions in front of the lens on the optical axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the point A prime. And the point B prime is located 1, 2, 3 divisions above A prime. So this is B prime. Hat is found on B prime. Now let's trace the image. Because the image is virtual, so it is dotted. and the scale is given by 2 centimeters along the x-axis and 1 centimeter along the y-axis. So this is it for part 2. Now let's move to part 3. Now in number 3 they are telling me let f be the focal length of L. So 3.1, determine using the path of a luminous ray issued from B and parallel to the optical axis the position of the image focus f prime. So we need to trace the path of a luminous ray issued from B and parallel to the optical axis, and using this path we need to determine the position of the image focus f prime. Okay, so first let's trace the path of this ray. This is an incident ray issued from B and parallel to the optical axis. We know that this ray will emerge passing through the image focus because always all incident parallel rays are related to the image focus. However, in this case we don't know the position of the image focus. We know the image B prime of B, and we know that all incident rays issued from B emerges from the lens as if coming from B prime. Then this ray will emerge as if coming from B prime like this. Okay, and we don't forget arrows on light rays, incident rays as well as emergent rays that indicate the direction of propagation of light. Notice that here in the question they told me determine, and determines means we need to trace and justify at the same time. So now let's justify the path of this ray. Okay, an incident ray issued from B parallel to the optical axis emerges as if coming from B prime. Okay, so now we need to determine the position of the image focus. Because incident parallel ray is related to the image focus, then the intersection of the emergent ray with the optical axis is the image focus f prime. Okay, so this is f prime. Now this is the tracing of f prime, and because they told me determine, then we need to justify the tracing of f prime. Let's say that then the image focus f prime is the intersection of the emergent ray with the optical axis. Okay, so this is it for part 3.1. Now in 3.2, okay, they are telling me deduce f. So what does f represent? F represents the focal length of L. So in other words, we need to calculate f, and they told me deduce because we need to use the part just previously before, and in part 3.1 we have determined the position of the image focus. So now we know the position of the image focus f prime, and we know already the position of the optical center. We can calculate f graphically, and whenever we need to calculate the focal length, we always start by writing the definition. The focal length is the distance from the optical center to the image focus. And now let's calculate the focal length. So f is equal to the distance from the optical center, which is the point O, to the image focus, which is the point f prime, and we don't forget the bar because distance may be positive or negative. So now f is equal to O f prime bar, which is the distance from the optical center to the image focus, which is in the same direction of the positive x-axis. Therefore, the focal length is positive. And now we count the number of divisions between O and f prime. We have 1, 2, 3, 4, 4.5. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. And this will give me, let me write down the scale. And this will give me 9. Because the scale is in centimeters, so the value of f will be in centimeters. Always, all quantities in physics must have unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. So notice that here the focal length is positive, which confirms or verifies that the used lens L is a converging lens, because we know that for a converging lens, the focal length is always positive. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.